I think I can't control it.
Yeah.
Right? Okay. So
Yeah.
today we'll start this one, so that you can after that apply on some practice
Right.
on the current network. So there is we are discussing, right, NLP problem. Always we can solve it using recurrent neural network.
Right.
So the thing is, like, why RNN, recurrent neural networks? The problem is, if you look at a deep learning framework, input layer, hidden layer, and output layer, it's just like this input is coming, activation, and output.
Right.
Yeah, but there is a problem. Recurrent. In the text processing, there can be a sentence, not a word. So we are not expecting we should convert into he or something. Based on a sentence, we want a conversion.
Right.
How to improve the baseball? Let's say baseball game. So might be playing in turf surfaces, playing in the weather, morning practices. What might be the answer? So the question is not like that we should be made with something, or just like we general neural network. What we do when we structured problem we solve using deep learning, we use a sequential networks. So we give the input, and we have seen that output is only a 2010 types. But we are not expecting something larger than one word, right? Let's say if there is 5 words, it should be the output always. So then we can think of that. Okay, this 5 is the output. It's a categorical variable. This is the repetitive of 5. No, but here it is not like that. So the uh, text can be of longer or short sentence.
That's right.
How do you do answers can be good or I am good, doing good. So we cannot control one output for one input like that. So that's why sequential network does not work out. So, and this is the first RNN networks which was designed like this, where XT is an input, these are input, and ST is the output. So this is input, this is output. And A is a neural network which gain information from previous step in the loop. So it is expected that the networks learn from the previous step. So here if you see, this information is learning from here. So I am good. If it is M, after M it should be I. So this information. So I, let's say, represented this output to V, but next time if I V, then what should be there? If it is there, then what should be this one? So based on if this was this, so output was there. So that information it wants. So when it is like I, then we expect V answer. So I am good. Let's say I am good. So when it's I, it expected the output V. Then M, when it said M next, so it will try to find out what was there in. So it tries to find out the previous information.
Okay.
The output goes one unit into the next, and the information is passed. So this previous information is required. So, but the problem is here we can only learn from the previous. This can learn only from the previous node.
Right.
So that is the limitations of RNN, and this makes the network predictions are performed very bad.
Bad. Okay.
This is given an example. Predict a blank word in the text. David, a 36. Going to predict a blank word in the text. David, a 36-year-old old man, lives in San Francisco. He has a female friend, Maria. Maria worked as a cook in the famous restaurant in the New York, whom he met recently in a school alumni meet. So this kind of words, long word is there. Maria told him that she always had a passion for what now? So here we want a network to learn from dependency, cook to predict cooking. So that means if cook is a word, the cooking might be the word we are looking like that. There's a gap between the information that we want to predict because we don't have a long information saved. Only we can learn it from the previous. And that makes our learning, we cannot assume that what can be. Maria, that she always had a passion for. So for that we have to read from here again, right?
Yes. Yes.
Suppose David as a teacher, she worked as a cook in a famous restaurant. Passion for
Yes.
cooking. So cook should be cooking. Might be because she worked as a cook. And there is no another term which looks like her hobby. So this is called long-term dependency.
Right.
So RNN does not work practically in this situation.
Right.
So RNN is this one where we can form one word, one or the other word in the input, and we get a HT output, and A is the network which get information from the previous steps. So information from the previous step means you can think of this like the activation function also. So see, because activation is where we learn, right?
Yes.
Anything in machine learning, it is learning from the graph only.
Yes.
So we say that information during the training of RNN, information goes in loop and gain which results in a very large, and again which results in a very large update of neural network model weights.
Yes.
So this is due to the accumulation of error gradients which during the update and hence result in an unstable network. So what it is telling is the weight, if there are many information or there are small information, and weight is the adjustment. And think about the logistic regression graph. So every small instance it will try to learn and the graph will change. Graph will change is in the sense, let's say it is coming like this, might also do the variation. So so let's say because this is here we are going to use the tangent or logistic regression, logistic, and right. So, sorry, this might be a tangent curve like this. So what happened? This graph may change, the logistic can change, or so how every word. So what it is for every word the logistic graph will make, but the learning things depends on the weight in the neural network as we learn. So the weight adjustment so has to be not very large and very small.
Yes.
So it is very small. Then what happened? The network cannot learn. Give me a second.
Sure.
Hello. Yes. I'm in training. I cannot talk to you. Call you. Okay. So that what happened is saying the information goes in loop again and again, which results in very large update of neural network weight. So the many times network has to run to perform something, it has to reduce the weight. As you have seen in deep learning, the many input layers are there. What happened? The weight has been adjusted, correct? So the weight has been adjusted, and when the many weights has to be adjusted for a small gain, I mean, once to get output, values of the output can large as to overflow and the results in NN values.
Yes.
So large, the values of weight can be become so large.
Huge.
So it can be indefinite values, or it can be very small, and that is called explosion. When it is a very large values, that is an explosion. Because with that weight, you cannot make the network learn. So it will overshoot. It will not convex. And other case, if it is very small, then it is called vanishing gradient. So that networks will take large time to learn, because if it is the weight is very small, 0.081 or 0.08 something. So these are the two problems, and one is called explosion and one is called vanishing gradient.
Right.
So vanishing gradient is just like in a neural network. If you see, if you remember a deep learning weight. One second is coming so slowly. 1 second. Okay. Yeah. So here it is. Let's say. Okay, let's say this is the weight, right? So everywhere these nodes has a weight.
Right.
So, but for the same, as you see these same nodes for first whatever everything will go through it, and it will balance the weight to learn. Again, it will come back. Again, will go all the inputs, right? All the these are the features. So all the records will go through it in a batch and get output. So now, if this is very less, so it will not help to learn. And if it is very high, then it will call the overshoot problem in the gradient, or here it is called explosion. So it is out of the range. So what is expected is like if you want 0 or 1 output, if it is fluctuating between 10 and -10, so it's not help, for example.
Right.
So that is how the weight should be, not in explosive, or it should not be vanished. Because every time it is not learning and it tries to get into the accuracy, the weight has to be improved. And we don't want the improvement as to go like weight very small, that is the learning has been too slow. So because of the vanishing gradient problem, RNN has been pushed to develop and reinvent called long short-term memory, that is called LSTM. So what is the architecture differences? Here it is like this. So if you see architecture, here I have kept it somewhere. So LSTM architecture is like that. The input will come, and there is self-recurrent connections. So four components: I input a neuron. This is a neuron. This part. Where is a self-recurrent connection? The loop is there. A forgot gate and an output. Forget is what is? Sorry, one input, one output, one forget, and one recurrent. Right? Sorry, once again, one input and a neuron and forget and output. So input, output, and neuron and the forget. These are the four components. So why it is called? Yeah. So what I wanted to tell you is like forget is why it is required because we can get into decision like we may have to understand, we may have to know, we may have to choose like I am playing or I am sleeping. Which term should come? Thereof the possibility will come 4 or 5 like that. So that times the forget will ignore some of the nodes, ignore some of the values which may not require. So idea is to bring that forward for that particular point. But the architecture is a little bit different. Here, if you see, X is
the scaling of information.
Minimizing. X is the scaling of information. Scaling of information is what it does. I mean, we have read like say scaling of the values to fit in the, I mean, fit by making it large or making it a small. So that is the same scaling of information. And plus is adding information. The plus node is
Adding information.
addition. And we use sigmoid and 10H for this. Because how we decide is, we decide something. Let's say after I am going or playing, what should be? So going should be yes or no. If it is no, we drop it. If it is yes, we take it. So the next node probability is like 2 things will happen. So that's why both the similar kind of graph is stated. So 10X is used because it has, you know that this is has a, it can map through the negative, right?
Right.
So map through the negative. So it is taking longer time to, it can hold for a longer time for the, to remove the vanishing gradient problem. Actually, it used 10H.
Okay.
And if you see T, H of T minus 1, so H of T minus 1 is the output of last LSTM unit. So this is the output of current unit, this is the last unit.
Okay.
And C is the memory we call. The memory why we call, C is the previous memory and this is called the current memory. Because see, so in when you design the network RNN, so we create embedded vectors of size that can hold all the different words.
Right.
And then this is the nodes, previous nodes, and this is the current nodes is talking about. We should hold the next information.
Okay.
right? So these nodes will have this information, this will have this information.
Information.
Okay, is the current. So these are the things happens here,
Right.
and the loop you have. There is a loop is there to find out the problem 10 is for gradient vanishing problem that occurs in RNA, and that is rediscovered.
Mm-hmm.
And because when it's a gradient vanishing problem, so that then stops learning. When the network stops learning, it don't have the capability. We cannot use it for training any long sentence.
That's right.
And that is why the scientists has recently only introduced, in 2014 only, they bring out this LSTM model.
Right.
Sigmoid can be used for forget or remember the information.
Mm.
Sigmoid has a special architecture enabling it to forget the necessary information. The Sigmoid, because as I say, there can be many inputs. So here it is a Sigmoid layer takes input xt and h of t minus 1. This is the nodes and this is the input of previous, and decides which part from old output should be removed
Right.
by outputting 0. So this information will go through a sigmoid or 10S graph. 10S to balance the sigmoid will decide on the nodes will be there or not, and 10S will decide on the weight.
Okay.
So in our example, when our input is he has a female friend Maria, the gender of David can be forgotten.
Yes.
So the subject changes to Maria.
Mm-hmm.
So this gate is called forget gate. The output of gate is f of t into c of the previous nodes and current function.
Right.
So here what happened? No, that is here we decided that because the current information requires Maria, so because the network cannot remember your last 5 days something. Up to some point it can remember. So the
Right.
possible word it will get to. I will try to get it in the next level.
Right.
Just you can think about many stones are coming. You are holding. Then you are just will have the filtering up. Get
Mm-hmm.
the stones that is required for your next playing activities. Sigmoid let decide which new information should be updated or ignored, and 10 is there creates a vector of all possible values from the new input.
Mm-hmm.
So after that, sigmoid we pass it, get from the previous to new, all the important keywords you get, and 10 which create a vector of all possible words. So now 10 will not create, we will create a vector that 10 which it will go through the 10 to learn.
Right.
So 10 will not create a vector. The two are multiplied to update a new cell. So this is the formula they have created like this.
Mm-hmm.
So this new memory is then added to old memory CTH minus to give CT. New cell means you understood, right? These two multiply, the sigmoid have a give a new information, and 10 is during the cell we have a vectors. So new information, new keywords will be there, a vector will be there. So the vector means function f of x of f of t f of x means t is 10 of x. So when we let's say integration of using 10h you in the method sigmoid.
Mm-hmm.
So if I apply fx dx that is 10 of each of all the words that is getting from sigmoid. So the result will be used to get these two are multiplied to get an update of new cell. So this whenever new cell will be created from that, and there we used to keep the old memory.
Right.
This new memory is then added to old memory. CT means we have some information and we get a new information by applying these things.
Right.
And then it's giving you the CT. So this is the formula actually. Here it is explaining. So the formula, if you look at, is a little bit difficult. So I prefer to go into this kind of material. So this way, its formula will work.
Okay.
So that is the explaining actually the formula. See, this is sigmoid of weight into output of previous into nodes plus some bias is also there. So this is actually the formula works like that. Okay, next step is to decide and store information of the new input. Next, to decide and store information from the new input. Cell center. This 1 second. Okay, so we have gone through this, right? So she has a female friend Maria. The gender of Maria will be updated. When the input is Maria works as a cook in the famous restaurant, he made recently the same things. Now his cooking should be updated. The new work whom he made recently a school enemy. The words like famous school meet can be school alumni meet can be ignored, and words like cook, restaurant, New York can be updated. So here it is saying, so some of the words we will not take out. So you cannot learn and all the grammars and that.
Right.
And might be there will be improvement and the work is going on. It's not so easy to derive a formula. So at the moment the formula is like this only. Take the important keywords. Finally, we need to decide what we are going to output. A sigmoid layer decides which part of the cell space we are going to output. Then we put the cell to the 10H. So sigmoid will decide. So cook will take or not, restaurant will take or not, like this. Yeah, or new work will come or not. Then we put the cell through the 10H, generating all the possible values, and then multiply it by the output of the sigmoid gate. So that we get the output of the parts we decide. So that is the previous formula I was talking about. 10H. So tangent of 10H and sigmoid of the output will be multiplied and get a new output. That is the predicted output. For the particular, I mean, next node. What's the next node?
Right.
So this is what the actually internally works. So anywhere neural networks you work, so anything will come as a text. So if you see, this is the word, right? So that day we work on something where there is a 20 different categories there.
Okay.
And here it is a sentiment analysis problem is like negative sentiment or positive sentiment. So it's again a binary problem.
Right.
So the thing is when you work and wanted to train using LSTM model, so that day we also train using a sequential model, but our text was very straightforward. We always had a heading, right? Something word is the same model I tried. It is totally scrapped. The same model that day we tried, right? So data was very, I mean, data was very organized. I think same heading was there. News data classification. I'm talking about. So it was giving a good output, some 90% accuracy or something.
Okay.
Yeah. So the previous example I was talking about, the news text classification. Now
Yeah.
problem can happen. Say if your input is like this, that something is not very organized and like not a document that like that news classification, which is
Yeah.
error or something.
In
So
news,
that
in news classification, like it was like very much properly organized by the categories and everything. So it was very easy to learn for the model.
yeah, yes, yes. So that was easy to learn because tagging was there, some kind of header was there. So first thing we need to tokenize it and convert into integer,
Hmm.
like say 2,500 words.
Right.
So it has created a big word so that can occupy all the keywords.
Hmm.
So I think uh, so when I build the LSTM, so he's saying that there are two hyperparameters, the embedded dimension,
Hmm.
input sequence into the sequence of dense vectors of dimension.
So
Embedded
Jimmy,
dimension
like
that means this one.
the hyperparameters, we have not covered it, right, up till now?
Yes, hyperparameter is what actually. So I have to cover it. So every algorithm will have a different hyperparameter.
Okay.
So here you don't have a justification. So see like embedded dimension.
Hmm.
You're taking out 20, 120. So this is the parameters that is going to put in the networks. And what would be the base parameters? What should be the what are you going to take it? So that is the thing is talking about. So here I don't see any way to this is first. So way to find out which one should be. I mean, so input sequence means what should be the size dimension you are going to take.
Hmm.
So in RNN, I couldn't find anything that this you can decide the matrix dimension, but should be capable of occupying all the keywords.
Okay.
Yes, so hyperparameters. So we have to cover for random forest
Hmm.
and neural networks. So when it comes to neural networks, uh, so hyperparameter will come from the gradient descent. So
Okay.
learning rate. So how it is learning is good or bad. I mean, what should be the parameters should be tuned so the learning will good. So in neural networks, I think if you are there, so combine, consolidate everything.
Right.
Let's, I mean, I will give you some example of this kind of thing, then we will take it out.
Okay. So
Okay, I will take you one through example. I think I already have some already built example. The implementation wise will be more comfortable, I think. So I will show you then.
okay.
So I'm just checking. I didn't get time to check this. The example was this one or somewhere. I mean, or the other folder may have. But it seems LSTM this one only.
Okay.
this one.
Sure.
Okay, so this is the example. So there are two programs. One second, the other programs. So here it is. Here it is reading from the JSON file and tokenizing it,
Okay.
and it's removing the duplicates. So there is not a thing removing. So every unique words is taken out using. So I will go through it. So there is one more file is there. So okay, so okay, I'll follow. I don't know where I kept it, so I'll follow from there. Uh, yeah, so there is one trick is there. So here what happened, no? That the data we are going to. So there is a link is there. So I'll go to the link. So because I can find out the program. So data.json. If you look at this file, data.json. So it is a question answering file.
Mhm.
So see, this is a question answer. The pattern is this one, then the response would be this one.
Right.
This is basically a chatbot. I mean, if you wanted to develop from scratch,
Mm-hmm.
so then you have to use LSTM model. So this is a pattern, then this is the response.
Response. Okay.
So this might be a different sentence of in the patterns, and the expected response would be any one of these one.
Mm-hmm.
How to create such a model? So that is the question. So
Question. Okay.
unfortunately, it's a LSTM model. This gives me only 33% accuracy. While it
How much?
is saying that 66 should be there by this
Okay.
network. So So the program is here. It is see open data.json as JSON data. So JSON.load. So it is loading the data
Right.
completely in indents. So here it is the complete is there. So now if you see there is intents in intents, right? This is intents. So this tree has an empty list. Empty list are there.
Right.
So for intent in intents, what is everything is loaded as an intents. So there should be we should have given other name. So in the intents, that is the intents is the complete things. If there is a term called intents inside it, this one, right? So then for if we are inside this one, that means intents. You understood, right? Because this is the total JSON file.
Right.
So then pattern in intent pattern. So if it is in intent again, intent is this one. Inside this one,
We look for patterns.
if there is a pattern keyword is there,
Yeah.
then it is saying what pattern in patterns. NLTK word tokenize pattern. So it takes you this one, right?
Yes.
So every time it takes a pattern, every time it will go for a pattern. So then it will find again here. So all this will it will take it, all the pattern. And it gets an NLTK word tokenize. It creates comma separated word of all everything.
Yes.
Right? From these all words. This pattern, everything. So add to our word list. So this is saying something is what is the words here? So W is concatenating this, adding to these words, the list of words. And the documents is what? Documents that append. So here it is focusing on creating the document name. Document name might be this one. This one greeting or this one I think they are targeting. Document is a W intent tag. Tag, right? So
right.
So if intent tag not in class if intent. So what is this? So for intent tag not in classes. Okay, classes will be initially empty. Intent tag. So all the tags tag name it is attaching. What is the tag?
Right.
And our main thing is like you have to in words. Here we have created words. For W in words, if W not in ignore words, if it's not a question mark, then take all the words that we have gathered.
Yes.
And then steam with the lowercase letter.
Okay.
So the steamer method that day we found somewhere, right? So limit is a steamer. So you can go through it the steamer.
Yeah.
So these are the method you can use it. So that day you asked me, NLTK what we can do.
Yeah.
And the KNN. So steamer NLTK. So one way the art is to build the words and create a vectors. And after that we'll be applying the LSTM.
Okay.
So schema has many things there. So out of that, what we use? Only the lowercase letter, nothing VFD.
Yes.
The plural numbers and that.
Mm-hmm.
So basically, the dictionary related things we can do. So in a word, the sort of list of words. So created a list of all the set of words that is
Right.
not duplicate. Why we use set? Because not to create a duplicate.
Mm-hmm.
Understood, right? So
Yes. Yes.
basically, we are getting all the words, and then we don't want to duplicate words.
Yes.
So
Yes.
that's why we create a set, and then we keep it in a list.
Yes.
And again, that list we sort it out.
Yes.
So then make a sorted list of unique words.
Words. Yes.
So this is the words.
Mm-hmm.
This is what we require now. What we have to do now. You remember, right? Tokenizer.token.
Right.
Yeah. So that thing we have to do now. So this is a tokenize. So let me find out the other file. Okay, I got. I remember. I think it is lying here only. Okay, so it's there only. So here, from here we have seen, right? Kind of similar functionality.
Right.
So this is another program. So where we keep the keywords up only.
Mm-hmm.
Exactly the same program I will give you. So this is see. Again, it's trying to keep this sentence and train, and we take it from JSON file.
Right.
Correct. So here also is doing see load the data.json is reading, and it is for testing purpose. They keep it for testing purpose, not used for that.
Right.
So this is another way that we did it manually. So here it is we are reading only. And categories to train for. So what is the categories for the data? Response. Categories will be response.
Responsive.
So here it is not a single word or 4 or 5. We have to find out how many different words are there.
Right. Right.
Okay, so list of data dot keys. So what is the data? So load data, JSON data in that keys. This one is a category. Sorry. This is the category. They have put it like this. This is not the output. This is the input. What is the output is not that. This is put as a category. So if this is the input, they put this is the what is the problem they are doing? I will tell you now. So if this is the input, again there, if the category is this one, if similar kind of sentence will come, they will find out okay this belongs to this category, and response with this one or this one.
Right.
If this will come, this belongs to goodbye category, so response with this one. So there can be many type of problem you can solve.
Okay.
So they get a keyword of the categories and list a list of tuples of word in sentence and category. So words,
Right.
data of each category. So data of each category. That means in key, whatever data is there, in every sentence they do remove punctuation. So here it is taken differently. So that is the other way we took it. All the data we collected in that particular method, right? So
Right.
in any ways you can solve it. There is different way. There is here it is taking out the individual words, sentence. In this category, the data, these are the sentence.
Right.
So this might be a little bit difficult code, but in NLP you should have this kind of code ready. These are there
Right.
to work on it. So everywhere you will see that the basic will start from here only. That's why I'm keeping like this.
Okay.
So each sentence will be there. Each sentence again word tokenized. All word will come out, and again whatever we did the last one file will be same. Like
Okay.
this. So word or exchange. So in this words, so ultimately we are receiving it here only the same thing we did in a different way.
Right.
Up to extend, right? So adding the and docs is the something list where we put a is category name. So that means what we can do, what is now we can think of, we get all the words from this one like that, and if this is the category, so we are going to get the output.
Right.
So anything a new sentence will come, you will try to find out the pattern. What is the pattern? So I keep it like this because I run this code in Linux system.
Okay.
And it was not a good it was not performing good. So in Windows it fails many things. So many libraries it created problem I think. So we can also try in the Windows only.
Okay.
Might not be, yeah. TF-Learn was creating problem in Anaconda, but TF-Learn is another package like a Keras.
So that means that so you were not able to do this TF-Learn in the Anaconda, right?
Yes, mine was problem was there. I will again run it now. We'll check.
Okay.
So there was some package missing and was could not resolve it. In not my system, even one student, he was there for many days, 10 days. I asked him to try something to integrate with the chatbot. I was only doing, asked him to continue to learn.
Right.
Physically, he was there only. So, but thing was in Windows, we cannot resolve many issues.
Oh.
But in Linux, it was now no issues there.
Okay, that means that I will not be able to run this on the Windows. Okay.
I'm not sure. You have to try because this library is not any straightforward. TF-Learn is again an important library, but is sometimes Windows does not support this nicely.
Okay.
So what is the thing? So see, here we get the words and docs.
1 second.
So we are getting the words, individual words, and category.
Jimmy, I will be back in a minute.
Yeah, sure.
you do smoke? Okay, great. I have that.
Yeah, Jimmy.
Okay.
Jimmy, I'm back.
Okay, you're right.
Hey, Jimmy, I'm back.
Correct. So here it is. We here till here we get the individual words, document name, and the categories. I think I should run it once again, then I can show you the output only.
Yeah.
The interesting problem actually.
Yeah.
And I think first time you are seeing that there are many loops and something is coming, right?
Right.
So you have to give time to this kind of problem. Even I forgot some of the steps, so I'm just looking at the code actually.
Mhm.
So So all the steps are running in the same one step only. So it will break in between, and there only. So the best way to divide this program into many steps and run one by one. Small.
Right.
So here it is breaking. Okay.
Uh,
Data.json. So I'll put it in JSON file is not. So I put in the main program so that it will be easy for to visualize the programming point of view. You can this kind of code can be assembled in any other Python code. Here it is not no issue, right? So till here, so if I put it in data, print it. Okay, it is. So this should print it. It's not printing here. So if I put it something, if I call this method, return file. Punctuation. Remove punctuation. So this method should come down actually, right? When you run individual steps, so because we are working on a main, right?
Right.
We are working from the main method. So this text, this is not the first step to run.
Mhm.
See, because see here each sentence will have to cover, so it should work from there. Okay. I'll put in the one file because I created like this, not serially, rather than a program I created. The data.json again. So I will explain you, so you can run it, and so next time we can discuss it. So
Yeah.
here it is created, right? So till here it is working. So but this failing down, excellent. This kind of methods is not found. This is Python method. Till where it is running, so it is failing back. So this is not working. So I have changed it, and I don't know I kept it or I, because excellence is something outdated.
Right.
So if you search it, you will find out a different method for that. Only sorry, range is required. I think I remember. So remove punctuation will remove something. I think question mark and all.
Mhm.
Unique. See now this is not defined. So those are the things need to fix. Uh, something was there. Unique is again not. I think UTF-8 or something conversion is required. So if you check on the date, you find out this is not supported. Accordingly, you have to modify it.
Okay.
So that is actually work. I mean, you're also some. I mean, practice will happen.
Yeah.
Error is good to have actually.
Right.
So remove punctuation and tokenize it. Tokenize, we have already checked it up to here. So creating the words and the documents will have the category. Correct. So we put it words and docs, doc name and categories. So this you can print it earlier. So once you fix it, you will be able to print this one.
Right.
And then we created a bag of words.
Mhm.
So bag of words of each document into a list. What is doing every document. Every document is saying document. I think is docs. So docs. If you see, doc is category.
Mhm.
So every category, whatever word is there, it is initializing and tokenizing words in the pattern, and then this. So our training will do contain the bag of words model, and output row will tell us the category that belongs to.
Right.
So training, what we did now, we have seen the words in the this one input.
Right.
Here, this is the input. So now in this model they are doing. So if so here it is here one second, one second, one second, one second. What time it is? What time it is? It will be go as a question. What time is it? Go as a question, and it will try to predict. So predict time. Predict will have to get up. For that is require a training. Training will need the sentence. What time is it? Right. So what will be going to match? There only you can find out. I got to go now.
Go now. Right.
Time. So is there is time is there? So I don't know. This example might not work very good with this one. Time is any time is there, right? So time is there. So time is what time it is should go to hours, I think. So there is
Yes.
what it is not working very good because there is a confusion is there. Tag is hours, so the time related thing should go here. It is what time it is. So basically, it is creating a training. This our we have a training required, right? Always. So basically, if you look at this one, train x is equal to what? Training 0. Training is what? NP array training. Random shuffle of training will have bow all the individual words. Bow is what? FN tokenized words. Tokenized word is word only, right? Individual word.
Right.
For word in this one. So the individual word what we found that we formed, if you look at the code, we form it to get the training data.
Right.
If this is a training data, what is the category? Training of 101. If you see this one in file. So training has two things, right? Bow and output bow.
Right.
Output bow has what? Categories.
Categories.
Understood, right? So the word input word, we give it a training data, and the category, this one we're giving to the predictions output.
Right. Right.
Understood, right?
Yes.
And so then if it belongs to this one during the training we found there, then idea is to get the response from here.
Yes.
So here length of train of x is taken. Bigger words, and bigger words will be what I mean list of all the words that have a 0 or 1 0 number 0 1 numbers. Individual words with 0 and 1 numbers. The tokenize Keras tokenize method we discussed right last time.
Right.
Similarly, this one is a Python method.
Okay.
So the length of this is taken as the input because all the data are lying in the one row. Then you have to take as a column, right? particular, you have to take all the consideration, right? If a row have hundreds word, then what you will do? 100 numbers. If a row has a matrix of a row, if a matrix has 100 keywords in the first row, then your size should be this one, right? Because the column size will be 100 then.
Right, right.
This is why it is length of x of 0 it is taken. First row.
Right.
Only one row's column length is taking, and that is the input. And fully connected layer of 8. The middle size is given 8. So I think it should be increased something this one.
So one question, Jimmy, this TF-learn is similar to TensorFlow, right?
Yes. Tensor inside TensorFlow is already using. See TensorFlow.
Oh, okay.
So TF-learn is like Keras that's work on top of TensorFlow.
TensorFlow. Okay, got it.
And there is activation. We use softmax. So this is this word, right? So LSTM is not used, correct? So we have to use.
Sorry, one thing. So if it is the same as Keras, so since the TF-learn portion we can implement even with Keras, right?
Yes.
Okay.
Yes, you can try it.
Yeah.
So this is using softmax. So it is a trained. This is a step for TF-learn. This is the two middle layers is there. These two. And this is the output. And it's 100 epoch. So this you can see. So here it is trained, and there is a output. So idea is what you can explore it. You can now increase it, change the model. Then we will use LSTM model and see how can we increase the accuracy. This JSON file you can increase to 100 limit, right? There is no limit on it.
Yeah.
Google and all, if you see, there only this option is there. You put this word, what is the output predictions?
Right.
So that they have already created good neural network. That means so. From this program itself, you can start and keep on R&D. I mean, it can be extensively increased. So idea is dump the words and create a network using a word vector, and then create a neural network, and then you train. So that is art only here, and that is a difficult art. So please, I will send you. I have another class after the class immediately.
Okay.
You will be waiting, right? So, or at least 9:30, I will be immediately. Please ping me. 9:30, I will send you this file.
Okay, that's fine. No issues. So, how was your presentation yesterday?
Oh, that is chatbot. No, that guy yesterday, because I put some, you have to do agreement and all. So they are saying that, I mean, they are also like this one saying why he's saying. So they asked the video of why should do a meeting. They're saying.
Oh, okay.
So I sent a video. It's okay. I mean, then I thought, who are that big party? They are only doing a digital marketing. They don't know about the software.
Right.
If I can have everything, then I can go. There are many accelerator programs waiting.
Right.
Next NetApp accelerator is there 15. So anywhere if there is a good product is there, then don't require somebody to, because they are like not a gentle salesperson. I mean.
So they are yes, yesterday with whom you spoke were not like the venture capitalists, the guys who put the money. They were like some marketers, right?
Yeah, there are some marketers. So they're saying there are more than 1,000 small companies they know, and they have tie-up. I don't know how much is they're saying, but they're saying they're the branch of this one only.
Do they charge you money for marketing your product?
No. They have a market. They wanted to sell it. They don't have a product. Already a fresh work company is there. In 2010, they have come in the market from Chennai. Now, last year they gone to $1 billion company.
Oh, okay.
Fresh work. So they're competing now with Salesforce. It's a billion. US also they have office in now. So initially they are all business process inside automation they did. Business process now with different chatbot, QA, FAQ bot. Now they don't have the small market segment, only the middle and big companies.
Okay.
But the potential and money is too high in these sectors.
Okay. So they were not giving you money to build your product. They're like buying your product.
No, then I'm also paying. I also need somebody to give me boosting. So I thought if I can build a SaaS product, so I'll create something UI that can that can be easily installed in the customer, but will be using the backend.
Oh,
It will be integrated. Then they cannot do anything.
okay. So like in India, like for example, like here in like US, like how the people work is that they build a product, they go to venture capitalists, they present, and someone likes them, then they give money. Otherwise, it's move on. So how does it work?
Yeah.
How does it
Actually,
work in
not a
India?
good idea to be behind them. Good idea is to find the market. Best way is to software. I have seen that they are going. One, two, the guys, they are from Karnataka itself. So they got some work from a small bank by some contacts. Small bank, not big bank. But they got some use case, right? And some business. So 1 year they got money. They said the 70 lakhs their revenue. Small company, that means they know somebody, father or somebody, they to get a
Yeah,
work.
yeah.
And 1 year they put effort, and now they are showing that we have something. So
Some client, yes.
we have some client and our product. So best thing is to build. Even the Steve Jobs also when he started, he didn't build the Apple. So first thing he got somebody said that give me 100 system.
Mm-hmm.
He took loan and all with his father's money and went to buy parts. And that time it was difficult to build a computer. So he and his friends sold it. After that, they got a boost of. That is the thing. So I thought if they are going to sell it, if I get revenue in 1 year, I will be able to build something good. Then I'll go
Yes.
for investor.
Yeah. Makes sense.
Other way, if you go to the investor directly, after some time your confidence also go down, everything will go down because they will play with
Yeah. Agreed.
you.
Yeah, it's a tough thing.
If you have money, somebody to invest or something, let me know. So we can US investors, some people are there who wanted to invest and jointly work on it. We can do it.
Right. Okay. So if you get some investor or some revenue in your company, that builds your profile much better. I agree. Because like if someone is looking to put like say 100 lakhs and he sees that you are making 10 lakhs, then he has a more confidence.
Yeah. Investor I have seen in 1 or 2 meetings only there. They will put 3 crores, wanted to put 3 crores money if you have 50 lakhs revenue, 50 or 60 lakhs.
Yeah. So actually that means they are not putting venture capital money. They are like giving like a uh,
Yeah,
some
lenders.
multiples of the revenue means that it's more like they are covering their bases.
Yes. Indian investors are very clueless about business. Somehow they
Yeah.
succeeded in one business, sell their US this one. They have 100 crores, 200 crores in pocket. They were in the US earlier, and they are not very confident. So they wanted to be very safe.
Yeah. Even in here, US, like it's much difficult to get like venture capital money. But like here, people invest like if they feel the potential in the product, they will invest even if there is no revenue. But again, there are very few, maybe 1 in 10,000. Here also, people like to see revenues and everything. Agree, it makes sense.
Uh, India also a lot of companies going on, but I think that is not big companies. Not a lot of potential companies are not there because that day I don't have anything, but still they have shortlisted my website.
Okay.
Something I have to build.
Yeah.
Okay, then see you. Wednesday, Thursday,
Yeah.
sorry. Tomorrow, right?
Thursday, yeah,
Thursday.
Thursday. Because like I have to play with this thing, so let's do on Thursday then.
Okay, sure.
Okay, thank you.
Thank you.